Alright guys, we're back this week with experiment 27, the chiral reduction of ethyl acetate, you know what I'm saying, you can read, optical purity demonstration. This experiment described in experiment 27a uses common baker's yeast as a chiral reducing medium to transform an achiral starting material, that being ethyl, you know the word, into a chiral product. When a single stereoisomer is formed in a chemical reaction from an achiral material, the process is said to be enantiospecific. In other words, one stereoisomer, the enantiomer, is formed in preference to its mirror image. In the present experiment, ethyl S3-hydroxybutanoate stereoisomer is performed preferentially. In actual fact, however, some of the R enantiomer is also formed in the reaction. The reaction, therefore, is said to be an enantioselective process because the reaction does not produce one stereoisomer exclusively. Chiral gas chromatography and polarimetry will be employed to determine the percentage of each enantiomer. Generally, the chiral reduction process less than 8% of the ethyl R3-hydroxybutanoate. In contrast, when ethyl acetate is reduced with sodium borohydride in methanol, the reaction is a 50-50 mixture of R and S stereoisomers. A racemic mixture is formed because the reaction is not conducted in a chiral medium. In experiment 20b, you will use NMR spectroscopy to determine the relative amount of R and S enantiomers produced in the chiral reduction of ethyl acetoacetate. This part of the experiment requires use of a chiral shift reagent. Whew, that was a mouthful. Okay, so as you can see here, I have my water. It is at 35 degrees. I have 7 grams sucrose, 7 grams baker's yeast, my hexanes, and my ethyl acetate. I'm just going to do experiment 27A right now. So I'm just going to start by adding these into there, and I'll show you what it looks like. As you can see, I added both of them in there. So you can get a top view. You see it's kind of cakey on top, so I'm going to disturb it some more. You can tell I've already done some work with my spatula here. Just trying to break it up, get it all incorporated. We're going to let it set here at 35 degrees, maybe even 40, for about 15 minutes. Alright people, we're back. It's been 15 minutes. You can see it's really cleared up. I mean, it's nice and consistent. No clumps or anything. Good mixture we got going of yeast, water, and sugar. Now I'm going to add 3 milliliters of ethyl acetate, you know what I'm saying, and 7 of hexanes into here. And then I'm going to let it go for an hour and a half. And it's going to thicken up, and it's going to produce a little bit of heat. So I might just turn this down a little bit, add those in, and just keep it moving is the goal. See you in a second. Alright, I've added the ethyl, I'll just show you the word. Added 3 milliliters of that, 7 of that. Now, you can probably tell the noise of the magnetic stirrers is definitely different. And I can tell it's thickened maybe a little bit so far, but you just want to keep an eye on it over the next hour and a half. I'll check in periodically maybe. Alright guys, it's been about 30 minutes. You can see it's a little thicker. It's a little thicker than it was before, yeah. I feel a lot more resistance stirring it, but it's more soupy. Like I said, it's been about 30 minutes. We have an hour left. That's just an update. Remember, in here we have the yeast, sucrose, water, ethyl, acetate, and hexanes. I'll check in with you guys after another half hour. Alright, it's been about an hour now. You can see we're still at 30 degrees. My thermometer has been staying pretty constant at about 30. So I'm not worried too much about temperature. You can see the consistency is thickening a little bit. I can definitely feel it when I stir. Feels kind of the consistency of milk. But yeah, that's just another 30 minutes. Alright guys, it's been the full 1 hour and 30 minutes. As you can see, we have a pretty consistent color, pretty consistent product. I'm just going to put tin foil on the top and let this sit for about 3 days. I'll get back to you guys after that. Alright guys, I've let this slurry sit for about 5 days. That's my 5 grams of acetylite. I'm going to put that into here and stir it for a minute. I'll let you guys see once I get it in. Alright guys, I've added the acetylite. It's stirring, as you can see now. I'm going to stir it for about a minute, make sure it all gets incorporated, and I'm going to let it settle until it separates back out into solids and liquids. And then I'll use my Buckner funnel. Alright guys, it's been stirring for a minute, so I just turned it off. I'm just going to let this settle back down, try to get it not so cloudy. See you guys in a second. Alright, so I've waited about 10 minutes. As you can see, the solid has settled to the bottom. So I'm about to use my Buckner funnel to filter everything out. Alright, so you see I have my filter paper here. I'm going to go ahead and turn on my filter. You can hear it now. And I'm just going to wet my paper. There we go. See down there. There we go. Now I'm going to add my cheesecloth. So you can see I have my cheesecloth added. I'm just going to wet that as well. No, just get back up there. You want to make sure that all of the Buckner funnel is covered with the cheesecloth, just so we're constantly drawing air in so it doesn't get clogged up. Now I'm going to pour it in there. I'm just going to be sure to go super slow. Just pour the liquid first. Just going to let that go down. This might take a little while, so I'll get back to you guys. Alright, just finished doing the filtration. I already took the cheesecloth out, but I guess I should add the rest of this, huh? Remember, always wear gloves. Don't be like me. There we go. I'm going to let that finish up, and there's my filtrate, and then I'm going to move on. Alright guys, officially done with the Buckner funnel. So you got a lot of filtrate. This is about 20 grams of sodium chloride. I'm just going to put it in there. Should I do this without a funnel, guys? Should I? Oh. Oh yeah. Not really though. It's alright, I'll fix it. You want to add about 20 grams into there, just to make an aqueous layer more clear later. As you can see, I am not Kobe with the shot, but I'll just add some more in there. It just needs to be approximately 20 grams. And then we'll get started on the separation, or the extraction. You know what I'm talking about, with that thingy. Alright, so I just added the filtrate into the separatory funnel. I have 30 milliliters of methylene chloride here, and I'm just gonna add it into there. Boom. Now I'm just gonna, you know what to do from here. Same thing we always do. Shake it a little, release pressure, shake, release pressure. Try to get our product to move into our organic layer. You know what to do. You know what I'm about to do. Alright guys, after 3 extractions with methylene chloride, I have my product right here. Now I'm just gonna dry this and then evaporate it, and then I'll be done. See you in the next clip. So I'm going to put about 1 gram of anhydrous sodium sulfate in there, probably a little more. It's a lot of methylene chloride in there. And then just try to pull out the rest of the water. So I'm going to dry it with this, put in there. So I added about 2 grams of sodium sulfate just to be sure I dry it. And I'm just going to stir it for about 5 minutes, and I'll meet with you guys after that. Alright guys, I finished stirring for 5 minutes. Now I'm just going to dry this. I'm going to pour it into an apparatus to get it to dry faster. I'm probably just going to use the air right there. So I'm going to decant this off into a different vessel, blow some air into it, get all the methylene chloride to evaporate, and we'll see what we have at the bottom. Alright guys, so I've been drying it for maybe 15-20 minutes, just like this. I've got a pretty consistent amount in there. You can see it's about 1 to 2 milliliters. Not a lot, but you know, a measurable amount. I'm just gonna put that into my pre-weighed tiny beaker, and I'm just gonna weigh this out. I'll show you guys the results. Alright, this is the final data, at least for the percent mass is what you'll need. I'll attach the spectroscopy in the next clip, but here you guys go.